So welcome to this last session for the day. Yes, on version control for your research. My name is Eckhard Kadasch. I work here in Jena at the university at the Competence Center for Digital Research. And I'm joined today by my colleague Philipp Seba of our University Computing Center, who will also present later in that slot today. So, version control for your research. As you may know, as researchers, we use digital tools more and more, even in like disciplines that are naturally maybe not so technically inclined. We may be developing scripts to process data, manage data, create visualizations, maybe even little software or bigger software projects that other people use. And at the same time, we don't often have a computer science or software engineering background, so we might not be aware of the tools that have been developed in that field. And version control systems, or version control more generally, is one of these programs that are in quite heavy use in the software engineering fields, but maybe not so much in research. And today I want to show you, and Philip later will continue, how we can use these tools in our research to get organized, to go from chaos to more clarity. So, um, this talk we separated into two parts. In the first part, I will be talking about the basics of version control, the basics of Git, and how we can use Git in our work, and also a platform that's called GitLab, which we can use in conjunction with Git. And the idea is that you get familiar with what version control is and learn some of the terminology that people use when they talk about these systems. The second part, for the first part also, I want to thank Ryan Alcantara, who provided me with his slides that he used in a very similar presentation. I thought this was a great collection, and he was kind enough to share that with me. Um, for the second part, Philip will take over. Let's answer the question what version control actually is. So here we have the example of a PhD student, and he finally finished a paper or his thesis, and he names this document final.doc. And then he shows this to his advisor, and naturally, as it happens, you get comments and suggestions. So you go back to work and then revise your manuscript, save it under a new file, in this case, final_ref.to, some file name that makes sense to you in the moment. And this is basically already version control. And version control means that we create a record of different versions of the same thing, and we somehow organize that. Of course, it doesn't stay at one revision. So you get to the next one, your file names get increasingly complex, and maybe you clutter up your whole project directory with them until a point where you ask yourself if this was even a good decision to start this project. So this illustrates something, I guess, that many of us have seen, many of us maybe have done in our work. The same thing applies to software. So we might develop a script that does something for us, and then we add functionality, or somebody else uses it, adds functionality, gives it a new name. We fix some bugs, add more functionality, and after a while, we have a couple of those files, different versions of essentially the same thing. And we end up with the same problem that we clutter up our workspace. And after a while, we don't know which changes we made, why we made them, and what's the right version for a given task. And this is where version control helps us in helping us organizing this. And Git in particular is one very popular system that people use to version control their stuff, be it software or documents or maybe even data. So why should you use Git? So continuing with this example from before, it helps you to improve the project organization. So what we showed, or what I showed just a slide ago, is that you can really clutter up your project directory with many files. Git will help us improve organization there by only showing us the newest one. So we have only one version of our project or one version of our file, and everything else is then tucked away in a database, basically the entire history of versions that we had before, and Git will manage that for us. Also, using Git, we can recall line by line changes. So we can really look at different versions of our documents or scripts and see what was changed and recall why these changes were made and so on. Also, we can use Git to collaborate with other people, to share code and work together on a single thing. For this, we would typically use one of many available platforms like GitLab or GitHub. And these are basically online services, server application that lives in the cloud that we can talk to using Git, and that serves as a central hub for project files. And then people who want to collaborate there, they can use Git to get their copies onto their local machines, and then they can each individually make changes to them and then share them again with this central hub and merge their changes together and share them again with other people, with other collaborators. And finally, and this is to me personally a very nice feature, is we can, if we use Git, use version control, we can make changes safely because all the other versions that we had before, they are safely stored, and we can now go ahead and diverge from that without touching the past. We can always go back and start a new development, maybe start a new feature, do a couple of changes, and once we are happy, we create a new version. And then that becomes the most recent version of that script. And what this enables us, having this trail of versions, we can also go back in time. So having things versioned in Git enables us to check out every prior version that we have and see the changes that we made and be safe making future changes. I also want to talk a bit about the terminology I may have used already and that we will typically use when talking about these systems. The first one is repository or repo for short. And this is the folder of your project, and it contains all the project files and also the entire history that you manage with GitLab, or sorry, with Git. The next one is Git itself, and that's the tool that records these changes and saves them locally. And then I mentioned platforms like GitLab or GitHub or Bitbucket, and there's actually many more. The first two are probably the most well-known ones. And these are cloud services, and they offer a place to host your repository and share with others. And the next very important term is commit. And with commit, we basically refer to an individual version of our project, of the files in our project. And we can think of them as a snapshot of all the tracked files at some particular moment in time. So if we think back of this example earlier, where we would rename the file or create copies with new names, these would now become only one file, and then we add new commits, meaning we introduce new version of that file, and then we see only that file. So that way we create a chain of changes or commits or snapshots or however you want to call them, and they contain the file in their respective states and also some metadata like the date they were created and the author, and also a message that describes what was changed and maybe why the change was made. Okay, in Git particularly, we have three states that our project files can be in. And they also map to like a workflow, like a circular workflow that we repeat all the time. The first state a file can be in is the modified state. And that means you go into your project directory, you open a file, you make some changes, and then you save it. And then the file has some differences compared to the most recent version that is under the version control. So this means you have a modified file compared to the most recent one. The next stage is a staged file, and that means we mark this now modified file to be included in the next version, in the next commit. And finally, to create this commit, we commit the file, and that changes its state to committed, And that means everything that we staged before, that we marked to be included, is now included in the next version that we add to our repository. And this information is actually stored in this Git subdirectory that Git creates and manages for us. Okay, I want to briefly say a couple of words about the distinction between Git and GitLab, because these are two different tools. Git is the tool that we use locally on our machine, and GitLab and GitHub and these other cloud services, they are server or online services that we connect our local repository to. And this has one major benefit, and that means when we lose our hard drive or we lose our computer, we still have a backup. So other people can access this, we can share this with other people on these platforms, but also we can get a copy from there. But this also doesn't mean if we don't have internet access that we can't create new versions, because we can still work locally on our machine, create new versions, and once our internet connection becomes available again, maybe after a trip or after an outage, we can synchronize those changes up to the cloud server again. So how does the basic workflow then look when we use Git for us? And what I want to show you in these next slides is really this most central commands that we use for version controlling our project files. So in this slide, we start with a project that's already on, say, GitLab. And then it means there's a website where we can go to, and this website has a URL. Maybe let me go back to what I wanted to remind you is, yeah, this circular workflow that we will see now also in like the conceptual stages that Git offers to us. So we will see this mirrored in our workflow. So this means that when we modify a file, this means we have a working directory where we changed our file and saved the changes. And staged means that Git offers us this conceptual staging area where we can move our file over to be included in the next commit. And once we commit, our file ends up in this local repository. Okay, so now back to this idea of the GitLab or GitHub instance that already hosts a project that was started before. Yeah, this has a URL, and then we can use that URL to download the entire project to our local machine. And for this, we use a command in the terminal, and the command to download this project is git clone, and then we give it the URL to download the entire history. By the way, we use in these slides and also in the demo I will show in a minute, we will use terminal commands. But there is also GUI applications for all the major operating systems that offer you a window and buttons where you can use the same functions in an application outside the terminal. But I want to stick to the terminal commands here because this is what happens under the hood if we use Git. So we clone the repository locally. At the same time, Git will create a working directory for us that has all the project files in the most recent state. So we have both. We have this working directory, and in the working directory, the entire history. So now we can go ahead, change to that working directory, open files there, and make some changes. And this now means the file is not the original one that's from the repository. We have the file in this modified state. And then we can use the command git add and that file name to add it to the staging area. And that means now all the changes in that file, they are marked to be included in the next commit. And once we did that, we can use git commit to create the first new commit in our local repository based on all the changes that we staged before. And that means we can also leave out some changes and author this in chunks that make sense together. And this circle we can repeat a couple of times, create another commit, to make a change, add the file, commit the file, and create a sequence of commits in our local repository. So these changes, they are not reflected yet on the cloud service. They are not yet on GitLab. To do this, to upload them, we use the command git push. And this means now take the entire local repository and update the remote repository on GitLab with that new information. And git clone we only use in the beginning, and it might be that in between our changes, other people also collaborated and then push those changes to GitLab, and then we can use git pull to get changes of other people who also made changes to the same project, or maybe it was us from a different machine. So we can use git push to upload and git pull to download. Okay, so I want to show you this in action. And for this, I have this terminal here. And let me get a web browser. So I go to gitlab.com. This is how the website looks when you are logged in. And there's this blue button here that lets you create a new project. So let's click that. And after a while, you get presented these options here. So you can either create a blank project, or you can create from a template, or can even import an existing one to GitLab. For our demo, let's create a new one. So I click here, and then we see this form where we can give it a name. And then the second thing we have to choose is the namespace or the location on GitLab where it should live. And this is all the groups that you're a member of on gitlab.com, but it can also be your username. And I will choose my username here to put this project under my username directly. And then an important choice that you have is the visibility level, where you can either choose to make this project private, and that means only you can see this project and work with this project, or people that you later grant access. Or you can make it internal, and that means everybody who has a GitLab account or account on gitlab.com and is logged in can see this project. Or you can also choose to make this public, and then everybody can see all the information that you put there. So for this demo, again, I will just choose private, and then I leave this one checked here. This means GitLab will add one file to this repository on the creation, and this is a README file, a text file that's like the main documentation for this project. And then, yeah, let's create this. And we can see after a couple of seconds, GitLab created this new example project. We see a title, we see the most recent commit up here, and we see in this table all the files, which are now is just one file. And by convention, GitLab will show you the contents of any README file, any file that's named README below here, because it's by convention the central point where you put documentation in such a project. Okay, so now that we have that, we can copy the URL from here, get the code, and I choose HTTPS as a protocol. And then let's move over to my terminal. And here I can use git clone, and then I paste the repository URL. So it's on gitlab.com, my username, and example.git. And now Git will contact GitLab, find the repository, and create a new directory. It says here cloning into example, so I can change in the directory. And then let's open the contents with the file browser. And we can see, sure enough, we have the same file here. And I can also double click and look at this. This is a plain text file, and I see the same content that we saw on the website. Okay, so now what we want to do is we want to follow this circle, create some changes, and then add the file and then commit. So I will just delete the entire help text here, and then maybe capitalize the heading, and then I save this file. So it's now saved, I close, and now I can use these commands that I showed earlier. I can do git add, and then the file name, readme.md. I won't see any changes, but Git now remembers that I marked this to be included in the next commit. And then I can do git commit, and I will add an option here to add this commit message. So -m and quotation mark to describe the changes I made. So I will write clean up readme file. Okay, so it says me one file changed, one insertion, That's the change in the first line I made. And 39 deletions, that's all the lines that I deleted from the file. So now I successfully created my first commit, but um, it's not yet on the cloud. So what I have to do is to use, let's close that, git push, and this will now upload the changes to the cloud. It says, okay, I copied this to gitlab.com username and the example um, project. And now let's have a look here again. Let's reload, and I can see this is the newest commit. I can see now my commit message. And if you look at the file, actually it's shown here already, but let's click on it and see the plain text. It says, we see now we have the same change that we did locally pushed up to the cloud. And this is the basic workflow that we will follow all the time. And if I wanted to get newer commits from GitLab, I could do git pull. But because there are none already, it says, okay, everything is up to date. You can continue working. So this is Git in a nutshell. And I would say this last slide here is the most central one because this is the basic workflow that we follow all the time. Git has many more features to organize your developments or your changes. I want to briefly mention one of them, which is branches. So until now, we only did a serial chain of commits. That means we always worked in the main branch with our initial commit, then the change I just made. But we can also organize our changes in branches. And that means we actually don't change the main. We create a new branch and we can do some changes for developing new features. And once we're happy, we can merge back into the main branch. And that means the main branch we can always keep functional. We can screw up in the other branches in our development or feature branches, but we will always have a working main branch. And that's would be also my recommendation that if you have a more complex project, especially if you collaborate with people, that you use these branches to organize different branches of development, basically. And with that, I want to hand over to Philip, and he will show you like a fake but almost real project, how he uses Git for that.
All right. Thank you very much, Eckhart. I will start sharing my screen. All right. So now let's build a little bit on the foundations that Eckhart has laid out for us. So um, let me take you basically on a very streamlined and idealized journey, admittedly, of me, let's say, being a new PhD student in my group. And I have inherited a program from previous coworker that I'm now tasked to continue developing with. Yeah. And so let's quickly have a look at what the program we have inherited does and build upon such improved features that Eckhart has hinted you. In this case, I will show you the demonstration with GitLab tooling, which is somehow specific to GitLab, but the principles very much apply to other implementations. Yeah, whether you work on GitHub, on Bitbucket, on Git, they all work very similar. They offer similar features, but the exact syntax may be a little bit different. But that doesn't matter. So let's dive right in. So let's say I got a program which we got from our coworker, and it's a very simple program. It's example word counter. Yeah, it basically takes a text, consists of only 3 source code files, and it is able to give you a statistic how often a word in a text occurs. So let's build it. It's written in Haskell here. That doesn't really matter. Yeah, it's just one example program. Whatever you get your tooling in, I used Cabal Build now to compile it, and now we can run it. As often the case, we can ask for some help how to handle this program, and we will get a text now, namely Principiae Philosophiae Naturalis from Newton, and have a quick look at that. Yeah, you see it's written in Latin. It contains some funny Unicode characters, and we will put this text in our analysis program to get a feeling what we can get out from it. So I'm running our word counter program here. Tell it to count only the 20 most common words that occur at least 200 times. And if we run this, we get statistics like that. Yeah, and that is our example program. We will start from now to continue our development on that. All right. So the first thing to do is we will turn this into a Git project. Yeah, I create my project locally first. I make a Git init, and a Git init turns this into a Git repository. And I will now use a graphical interface to Git, which does exactly the same thing that Eckhart has shown you, but we can see it nicely. And as you see here, we get the unstaged area. So that what Eckhart has called the work directory. And it lists a number of files here that are present in your current directory. And you can see that they all have been added. This is why they have a little plus. Interestingly, here we have a lot of the compilation artifacts, because we are building our project within this directory, and we do not want to put compiled artifacts in our version control. They are generated from our sources. We do not want to track them. And this is why you have this git ignore file that I'm just creating now. And it basically tells Git that you do not want to track some specific files or directories. And if we go back now, you see they have vanished our build artifacts from our work directory. And we can now make our first commit with our original version of the word counter program. I give it a commit message and I commit it, and you see we created our first commit, nicely visualized here. And now we want to push it to GitLab. So as Eckhart has shown you, we will create a new project. I will use an empty one and give it a name. It's our word counter example here. You can choose whether it's public or private. In this case, I don't care that other people see it. Indeed, in many cases, it's certainly good if you make your research software open source and public, and we create or we select a namespace here. So again, here, my personal account. I did not get a README because I unchecked that mark, but still I can get the URL from here as Eckhart has shown you and register that here as the remote URL for that repo. So this is the remote point in the cloud that we want to sync it with. By convention, it's often called origin. And now we can push our local changes, enter our credentials, and synchronize our local changes to our cloud GitLab instance. And now you see we have this commit both on master and origin master, so the remote point. And if we reload, you see everything is here. All right. So now we have established basically what Eckhart has shown us. Our program is under version control. And now we can continue developing our program without the worry that we break something and cannot go back. Still, let's talk about the lesson in self-control. Usually it's a good idea, especially for software projects, to establish a test suite. Test suites can look differently. They are categorized differently. The most basic one of the tests you should write are so-called unit or property tests. They test singular functionality in your project, single functions, whether they behave correctly. But the more complex your program gets, or the more complex your project gets, the more important become, for example, integration tests, which test whether multiple components play together nicely, and full system tests. But for such a small example that I'm showing you here, unit tests are perfectly fine. And now our idea is that we want to continuously test with pipelines every change we make. That is, we can utilize GitLab to verify our code for correctness. But the first step is we have to write a test suite, of course. And again, this is, of course, somehow tooling specific. Let's do this quickly. I'm not digging too deep into that. But as an idea, we have three important functions. One is count words, which is counting words in a text and telling you this word occurs 50 times in the text. We have a combination function, which combines countings from multiple chapters, and we have this filter function. So let's say these are the core parts of our program that we should test for correctness. And depending on your language and tooling, there's a certain way usually to write a test suite. This is why I'm not commenting that too much. I'm adding a test suite here to the build system. yeah, and inserting a test suite here. And we're testing for a few things. For example, interpunctation can make different words. We are is a different word than where. Yeah, that makes sense. We should get this correct. A sentence mark should not make a new word at the end of a sentence. Yeah. Unicode accents should make new words. Andre is something different than andere. Yeah, we test whether we combine chapters correctly, and all that stuff. And we can run our test suite, in my case, with Cabal testing. You see, nice, everything has been right. You see, we added 2 files or modified one and added one to test suite. So we can make a new commit here, giving it a meaningful commit message, adding unit tests for text counting, and make a new commit. You see now, I made a new commit. It's only locally, but it's not yet on origin master, so not on our GitLab server. For that, we would have to push. But before we do that, let's instruct Git to run our test suite automatically. For GitLab, this happens if you put a .gitlab CI YAML file in the root directory of your repository. And we have to instruct it somehow how to run our test suite. And first, we define some global defaults. Yeah, in that case, we define a context, a Docker image in that case, in which our tests run. And this is a Docker image which contains pre-installed Haskell tooling because I have written my program in Haskell. Yeah. I also can set some environment variables that would be present in each step. Or here in that case, I'm using a before script, and before script is executed before each pipeline in each pipeline step. And I do so in that case to instruct my tooling to build everything in the repository directory so that I can cache reusable compile artifacts between pipeline runs. So now we can tell GitLab that we want to do our tests in 2 stages. Yeah. First is we build our program. Second step is we check whether our program also behaves correctly. So let's write our first stage. We can give it some name. I call it Cabal build here. It belongs to the build stage, and we do exactly 2 very simple steps. We get new package sources, and then we build our program. Cabal update, Cabal build. Second stage, we want to run our tests. And consequently, I named that step Cabal test. It belongs to the check stage, and we do something very simple. We run Cabal test. We can test whether our pipeline behaves correctly without pushing it. There's a tool for it called GitLab CI Local, which allows you to run a pipeline as it would be done on GitLab, so that we can check whether we did everything correct. You see, it runs these 2 lines here that we gave it, export Cabal here, pwd Cabal and Cabal update from our before script, and our script stage for Cabal build. It builds our dependencies in a containerized version, and this pipeline step has passed. We can test our second one, Cabal test, to confirm that also our tests run correctly in the pipeline. And hooray, they do. So we make our new commit, adding the GitLab CI pipeline syntax, commit that, and now we can push our 2 new commits on the master branch to GitLab. And when we go back to GitLab, the web interface, now you see we have this fun little blue circle here, which tells us a pipeline is currently running. So please wait for it. And we can follow their outputs live. You saw the 2 stages here that we defined. And gitlab.com is running our build step on a cloud server. Job succeeded. So let's have a look at our second stage, the test stage. Wait a few seconds. I speeded up. These videos would take some time otherwise. And you see our tests have passed. Everything is okay. And when we go back now to our main page of the repository, you will see that our pipeline has passed. We got a green check mark instead of this blue circle, and we are fine now. All right. now that we've established that it's not too easy for us to break our own code, let's talk about how we can enforce it. And the idea here is that we want to disallow a direct push to the main branch, or in my case, it's called the master branch. Yeah. So when you update main locally, you may not be allowed to directly push that remotely. Instead, we would like to use a feature branch for development. Yeah. This has multiple advantages. Eckhart has already told you about a few. Yeah. But an important point is you avoid a half finished or non-working code in your main branch, which ideally always stays clean. You can allow yourself to have a nonlinear history. For example, you can squash two commits or combine two commits into one, yeah, and clean up your Git history without breaking the reversibility in time on your main branch. And also importantly, if you work together with other people, you do not want to produce a moving target for coworkers because you're continuously changing code that they are building against. Yeah. And then we can use a so-called merge request, shorter MR on GitHub. They like to call it pull request, but it's the same, to merge code from our feature branch into our main branch. And we can do so while enforcing a few criteria. One is we can enforce the pipelines to pass so that it's not possible to push code that has a broken test suite. We can have code review from other people, and also we can give some helpful context and messages in the merge request to help other people figure out what and why we wanted to change it. So let's have a look at that. Yeah, when you go to your repository settings here, yeah, you can have a look here where you have the so-called geschützte branches, or in English protected branches, and you see merge is only allowed for maintainers, so people that have maintainer permissions. That's one of the roles GitLab offers you. And pushing via merges is only allowed for maintainers by default, and it's not allowed to force push. And that is actually what we want usually. Yeah. So that's certainly a good idea to always protect your main branch. Yeah. Here you can also see how your main branch is usually called. In my case, that's master. So let's do the following. I will revert a commit locally. I will go back to the last commit that we've made. Reset current branch to this commit, hard reset. And now you see remotely, we have a different state than we have locally. And I will not be allowed to directly push to that because that would change the truth and history that we have established remotely. And I can also not force push because we disallowed that. This is what we want. This is good, usually. Okay, so protecting yourself from yourself. All right. Now that we've introduced this additional safety features, and we learned that usually you actually want to use a feature branch, let's use a feature branch and try to improve our code. And maybe I'm not the best programmer on that planet, and I will break my code while doing so. In that case, I'm aiming at reducing the memory footprint of our program. For now, we are loading our entire text into memory and then creating our statistics from it. But that is not necessary. We can stream over our long text, yeah, and do this in constant memory. This is what I'm aiming at. And yeah, you will see that I accidentally break my code doing that, and how CI will catch that. All right. So let's start with actually creating our new feature branch. Yeah, we give it a name. I call it Streamly text because that's how it's going to work. We are a Streamly package. That's one of the dependencies I'm using for that. It doesn't matter too much to you how it works. Just that I want to improve my code now. I import some new dependencies that allow me that streaming. And then we are going to replace our main functions, count word text, by count words stream. That works in constant memory. So and what we're doing is we decode our text into UTF-8. We create single words from it. We filter out words that are empty. We are accumulating our results. and then we should get our final statistics. So it's basically doing the same thing that our original function did, but better. Okay. So now I have developed my new feature, and you see we have the git diff, yeah, it shows you what you've changed. It shows you what has left because you deleted those lines and what you've entered here in red and green. Yeah, and now we can stage these changes and make a new commit for that feature on our feature branch. All right. And now we push that local branch to our GitLab server. And can create a so-called merge request, which you find here on the left side in the sidebar. Yeah? GitLab has already figured out we've pushed a new branch, and it helpfully suggests us that we can create a new merge request now. You give it a title. In best case, you also give it some helpful description, what you did. This changes the implementation of the word counter function to a streaming implementation over the input. This improves memory usage. And now we create our merge request. So you see, we are trying to merge Streamly text into master, and you saw, it was a little bit quick, sorry, that we have a pipeline running for that merge request on our feature branch now. We already saw them, so there's nothing too interesting here, except in the last step. Namely, our test suite fails. Yeah, you see all these failures here, it is red, and GitLab has figured out something is wrong there. And thus you get this red cross here instead of the nice green check mark. Yeah, we were able to build our program, but it did something wrong. Yeah, check not successful. Now you see, we actually could still merge our merge request. This is not what we want. So let's introduce a second safeguard for us, namely that we can only merge a merge request when the pipeline has successfully passed, and you can do so here via the merge request settings in your repository. Here we were. Yeah, usually you want to make the check mark here at pipelines have to be successful for a merge. Yeah, that protects yourself from merging broken code. So let's get back to our merge request after we ticked that checkbox. Yeah, and you see now we do not have the button merge anymore, but set to auto merge. And an auto merge would happen as soon as the pipelines successfully pass, but not before, yeah? Pipelines have to be successful as this red little symbol over there. Okay, but first let's try to actually reproduce the error we have encountered on GitLab locally. I run cabal test, and okay, at least the error is the same locally. And you see, we have some strange behavior. Yeah, here, for example, we wanted to have what's laugh, but we got laugh with a question mark. So maybe I've just forgot to filter out some interpunctation. In that case, here the question marks and stuff like that. And usually it's helpful to have a look at the diff, yeah, the git diff, the changes of your previous commit. And actually, if we have a look at that, you see there was an additional filter function, seppunct, yeah, which I by accident omitted in my new implementation. Yeah, I just didn't account for interpunctation. So we should probably add that back because it has changed the behavior of our program, which we didn't want. So let's fix my stupid mistake. Yeah, git diff is helpful to figure out what you did. Okay, let's test, and hooray, if I actually respect interpunctation, everything works correctly. So we are creating a new commit with our fix. Fix the streaming word counter punctuation. Make a new commit. Now, there's basically no reason to have our non-working initial version as part of the main branch. So what we can do is, no, sorry, what we can do is to clean up the history of our branch, by squashing these commits into one. We just need one commit that implements our new feature correctly, not one that implements it wrong and one that fixes the wrong implementation. And that is something you can do with a so-called interactive rebase. And you see, you get the two commits on top of the last point of the master branch. And now you can select what you want to do with those commits. And we want to squash the fix into the other one to combine them and complete the rebase. And what we'll get is one commit locally that we want to push. We cannot easily push because that would overwrite remote history. In that case, we have to force push. And we only disallowed ourselves to force push to main branch, but we can certainly force push into a feature branch. That's perfectly fine. All right, so let's have a look back on our merge request on GitLab, and we wait for a few seconds for our pipeline, for our new fixed code to hopefully pass this time. Hooray! Yeah, now even on our pipelines, all our checks are green. So when we go back to our merge request main window, you see we have two green check marks, tests have passed, build have passed, and now we can actually merge that into the main branch. This is a merge that's happening now remotely on the GitLab server with additional safeguards and checks via our pipelines. And we can fetch or pull the remote changes. And you see we got a new origin master and now actually origin master. So the state of the master branch on the remote server is before our local one. So we have to check out or pull the remote branch to our local version. All right, so we have also successfully implemented a new feature while keeping it perfectly safe. So there's a lot of more you could do with GitLab stuff, many things I haven't touched yet and that are increasingly specific. For example, you can use GitLab for as a provider, as a package registry. You can push your Docker images there and distribute your pre-built code. You can distribute Debian or RPM images there, your Python programs, even machine learning weights, should you have trained, I don't know, a new large language. There's an integration for that on GitLab usually. You can also step up your game with pipelines and do something called continuous delivery. For the moment, we have done continuous integration. In continuous delivery, the idea is, for example, you're having the source code of your website in Git. And continuous delivery pipeline would constantly roll out the newest changes from your Git repo to your actual website. It pushes actively somewhere else. And of course, there's also project management features in GitLab that you could use, like ticket system, milestones, epics, time estimates, assigning workers to that. But for now, we have touched, let's say, the improved version of software development with that, protecting our linearly growing branches and using feature branches for changes, pipelines for automation, and safeguards and pull and merge requests to basically enforce good practices here. With that, I think we're at an end. Hopefully we've given you some introduction, more basic and a little bit more advanced on Git. And I think we are both open for questions.